the acid has been added. So now let's go right to the equivalence point. So the way I draw it should indicate that was not an equivalence point. So we want to figure out how much we need to add of the acid to reach the equivalence point. So the equivalence point, or the stoichiometric point, means that you add the same amount of moles of your titrant as you had, and so they're going to be equal to each other. So if you're adding acid to a strong base, you've added enough acid that you now have equal number of moles to the number of moles of base that you had to begin with. So we know we have 6.25 times 10 to the minus 3 moles of the base were present. So at the equivalence point, you need to have that exact same number of moles of acid. So we know the concentration of the acid we have and the number of moles we need. And so we can calculate the volume, which is 18.4 milliliters, or 0.0184 liters. So what would the pH then be of the equivalence point? We're titrating a strong acid with a strong base. What should the pH be? The pH should be 7. So somewhere around here, we're going to be at 18. So we can just try to draw a curve. And here we have a pH of 7 when we've gone to about 18.4 milliliters added. So when you titrate a strong acid with a strong base, you form a salt that's neutral, because the conjugates of a strong acid and a strong base are not basic or acidic. They're ineffective as acids or bases, so you're going to get a neutral salt. So if you're doing a problem with a strong acid and strong base, it's not a lot of calculations that need to be done with this point. You just need to recognize that your